Alright, hello everyone, welcome back to another programming challenge. Today we're going to be finishing up the Json challenge in C, and we will be looking at, inputting and outputting to and from files, which will be a little interesting because last time we did this I had some weird algorithm that was super specific, and I don't think it entirely worked. But this algorithm is more thought out, it's more methodical, and it is more of a, it just makes more intuitive sense. Alright, one sec. Alright, yeah, so we're going to be doing the output to a file, since that's super easy, because we already have a method to pretty much do that in the string stream, and then we will be going through the algorithm to input or to take data from a JSON file. So let's go ahead and hop into json.h, and we're just going to have our first, let me actually just switch over to the screen here. Should be good now, yep. Alright, so we will start in json.h, where we will have our method declaration here. So I'm just going to have it at the bottom here. So file IO, first one will just be return type void, and it'll be JSON write file, pass in JSON J, or actually let's do write file object. So pass in a JSON J, a char pointer path, and then boolean for prettify. And then we'll have a different one, void, write file object should take in a file pointer, fp, and then we'll have JSON write file takes in JSON J, and then this time it takes in a string as a path. So we can open the file in this method and then write to the file in this other method. All right. Yeah. So these will be the two methods that we'll work on right now. Thank you for the kind words, Crowleg. Yeah, OpenGL is pretty fun. I will be returning to that in a bit. We just finished the collision stuff, so it's I'm taking a little bit of a break from it, but I will definitely return to it with some more content. I do have to finish up some of the polishing on the collision system, but it will work eventually. Or it does work now, but there's a few bugs that need to be sorted out. So that will be coming up soon. But thank you for the kind words either way. All right, so we will start with. All right, so we will do write file first. The one that takes in the string as a path. So here what we want to do is we want to open up a file object. So we'll have a file pointer fp, and then fp is equal to fopen, pass in the file name, which is the path, and then the mode will be wb for writing in binary. And then next what we want to do is we're going to call the other method, so JSON write file object, pass in J, the file pointer is just fp, and then prettify is just prettify the parameter, and then we're going to say fclose fp. So this method will just allow us to do all that just by passing in a string path. Now for the actual write file object, it's going to be pretty simple because we have our string streams. So we have str stream out is equal to JSON stringify. We pass in J, prettify, init tab position is 0, and is dictionary value is false. So we're calling the lower level method here, not just JSON dump, because we want to return a string stream. We don't want a string, because the string stream, if you remember, if you watched that video, we have a method that writes to a file here, so we can simply just call that. So we will say str stream write file, pass in a reference to the file, which is out, The file pointer is just fp, whichever we passed in. The first is 0 and the last is 0, which will then be defaulted to the end of the string. That's awesome, Krolak, yeah. Once again, thank you for the kind words. Alright, and then we just want to clear out the string. So str stream clear reference to out. So that just clears the string. Oh, I just swallowed water in the wrong pipe. Hold on a second. Oh, that's good. Alright, I'm good now. Alright, so that's writing. Pretty simple. We can test that right now in main.c. And we can go ahead and do a little bit of JSON write file, pass an out as the object. The path we'll just say is test.json and then prettify is true. Alright, so let's go ahead and run this. Alright, and then we have a test here, and it has the exact values that we wanted, which is pretty fucking good. So yeah, it simply just takes the string stream that it generates from stringify and then just loads that into a file, which is right here. So that's all good. That's all good. Alright, let's go the other way around. Now let's read this data from a file. So I will put this off to the side, and I'm going to create a new file here. Stack.txt, and I'm just going to walk through what the reading algorithm will look like. So we're going to, pretty much like any parsing algorithm, we're going to start by going through the characters or the tokens. So char/token, and that will be some process to figure out how to parse those. Then we will be representing the hierarchy here of elements using a stack. So when you're really considering any sort of hierarchy and you want to build up a hierarchy, you're typically going to be looking at something like a tree. So if we were to consider this as a tree, I mean, you can kind of, even in Visual Studio Code here, you can kind of expand and collapse certain menus, which is a hierarchy, and it's a tree because the highest level node, the root node, is this object here, and it has 5 different children. The first child has a key of list 1 and the value is a list here. Second child, list 2 as a key and a list as a value. List 3 as the key, list as a value. Then float as a key, then a number as a value. Then a string 1, 2, 3 as a key, and then a string as a value. So these are each children nodes of the root node. And in the list, this list will be another node, and it has 3 different children, a string, a float, and a null value. So we can kind of think of this as a tree. And when you're thinking about building up a tree, you're mainly going to be looking at stacks, queues, but we're going to be looking at a stack today because that makes the most sense. So we will have the stack here, and then we will have an action that will correspond to the token. So let's walk through this. So we have our first one here. So the first one is just an open curly brace. The stack is now a dictionary. So we push a dictionary to the stack. So start dictionary, and we're also going to start a key. Or let me actually replace this with object because it's technically an object. Yeah. So we have the first token, which is an open curly brace. So we're going to start a dictionary, and with that dictionary, we're going to start an object. All right, and then we get an open quote, and then this will then be parsed into list 1. So we have list 1 here, and this isn't going to add anything to the stack, it's just going to be an object. So what this will do is we're going to have store string in key, and then with the semicolon we're going to still have the same object on the stack, except we're going to end the key. Alright, and then the value will now be the open square brackets, which will be a list. So we will then push a list to the stack. So object and list are in the stack now. And we have a start value, or this should be end key start value. And this will be start list. and then the list will also start another value. So we open up a list, and then we also want to open up a slot for a value here in the list. So then our next token is str1. Same things, object and list. We get to the end of the value, or not to the end of the value, but we're going to store the string in a value. All right, then we have a comma, which means that the current value is over, so we still have an object and a list on the stack. This time we're going to end the value and add string to list. Then the same thing with the 1.29. So object list, store number in value, then a comma. So object list, we're going to end the value, add number to list. And then the null, once again, this will just be treated like any other token. So list, so store null in value. And then the next token will be the closing square brackets. So this, now we're going to take the list and we're going to pop it from the stack, essentially. Is that right? Yeah. So we're going to add the null value to the list, or add null to list, because we haven't done that yet. Then pop the list. Then we get a comma, which is this comma right here. Then we're going to have an object still there. And this time, we're going to end the value, which is the list. So the list becomes the value. So pop list as value. So we're ending the list, or ending the value, and then we are storing the key value pair in the object in the top of the stack here. So all of these elements here, the string 1, the 1.29, and the null, they were all added to the top level element in the stack, so the list here. So these three got added to the list. Now that the object is at the top of the stack, we want to store the key value pair using this key as the key in the pair, and the list is the value. So yeah, the same thing will continue on for the other two, so I'll just skip those two. Then we get our next token, which I'll just skip over to the float. So we still have an object on there. So store key, or store string and key. Then we have the colon, which will be end the key, start the value. And we get a whatever that value is. It's an object. So store number in value. And then we have our comma. So object, and the same thing will happen. We're going to end the value and store the key value pair. And then the same thing happens with string 1, 2, 3. Object, store, we're going to store the string and key. And then we get our colon, so end the key, start the value. And then we get our string, which is whatever that is. Object, and store string and value. Now the last token is our closing curly brace. So we're still going to have the object, or we're actually going to pop the object from the stack now. But first we have to store the key value pair. The key value pair is the last key, so string 1, 2, 3, and the value is this current value here, the ASDF, or whatever we have there. So store the key value, and then pop the object as the value. And then once we're done, so \0, nothing on the stack, return value, which is an object. So at the end, the current value will be the dictionary, which is what we return from the method. And since JSON files only have one element per file, like one top level element, whether it be a list or an object, this will only be when the stack is empty. That's when we know we have our That's how we know that what element to return. So yeah, this will be fun to look through, but this will pretty much be the algorithm. Once again, the tokens that we're gonna have to look out for are going to be the open curly brace, the open square brackets, quotes, the double quotes, the commas, the closing square brackets, the closing curly braces, any numbers, null values, false, and true. I didn't have any booleans on here, but it would be the same thing as the null pretty much, where you just look for the tokens. Okay, so let's get to the coding. So this will be fun. So we will start in json.h, and we have to have 2 new constructor methods here. All right, the first one, so these are going to be constructor methods that return pointers rather than just values. So the reason why is because our dynamic arrays, which we're going to be using as our stack here, they require pointers. And we also want these values to be returned. However, if we just use the normal constructors, this memory would be lost once we finish the method, once the method returns something. So we have to store in pointers and then just return a dereference of the last pointer at the end. But we'll see how that works. So we're going to have two new constructors. So one is return type JSON pointer, JSON alloc type size, which is pretty similar to the one above, and we pass in JSON type and unsigned integer n. And then the same thing for JSON pointer, JSON alloc type, and we just pass in a JSON type here. So these are going to be similar to the other methods up here that do not return pointers, that just return the actual value rather than a reference, but it's going to be the same stuff. All right, so let's copy these signatures over. Let me find out where I want to put this. And then let me just find my reference here real quick. All right, here we go. So we'll start with alloc type size. So we're going to have a JSON pointer ret, which is equal to the malloc of the size of a JSON. So we're going to allocate memory for a structure of a JSON structure. We're going to set a type here. So ret.type is equal to type. And then we're going to store our default values. So switch type, switch on the type. In the case of JSON null, we're going to say ret.val.n is equal to null. And then break. For case JSON string, we're going to say ret.val.s is equal to an empty string and break. Case JSON float, ret.val.f is equal to 0.0 float and then break. In an integer, we're going to do the same thing, ret.val.I is equal to 0 and break. For Boolean, we're going to set the Boolean value to false, so ret.val.b is equal to false, and then break. JSON list, ret.val.l is equal to dynamic array allocate n. So where n is this argument that we passed in here. And and then break after that, and the same thing for case JSON object. ret.val.o is equal to hmap, allocate string as key with number, and pass an n, and then break. And at the end, return ret. You know what we can actually do is just have the null value be our default. So if some other unknown type is passed in, we'll just set it to null. And then we just say ret.type is equal to null. Yeah. And then just for presentation's sake, we can have the JSON null case fall into the default case, just to show exactly how that works. And then for alloc type, we'll just pass in, we'll say return JSON alloc type size, pass in the type, and then 0 as the size there. Just kind of creating a new method to have a default argument for the size, because it won't always be used. All right, so that's those two new constructors, and now we're actually going to be writing the input method here. All right, so we'll have a return type JSON read file object, pass in JSON-J, a file pointer FP, and then we'll do the same thing where it's JSON read file, where we pass in JSON, or no JSON-J actually, just a file pointer. Sorry, that's my mistake. So we read from a file pointer, or we can read from a file path, a character pointer path. So those will be the two methods here. All right, so let me just copy and paste these signatures over here. And we will start with read file, since that'll be the simplest. So as with write file, we're going to open up a file in the with the path. So file pointer FP is equal to fopen, path with, this time it's going to be a read binary, so RB. And then we're going to call we are just going to have a return value, so JSON ret is equal to JSON read file object, and pass an FP, then fclose FP, and then return ret. Just like that. Now for read file object, we're going to need one extra helper method before we do anything. And that'll just be to determine if a character is a number. We've looked at this with shunting yard. We just need this method here just to help us determine parse numbers. So Boolean character is number, passing the character C, and it's going to be the same condition. So return C is greater than or equal to 0, and C is less than or equal to 9, or C is equal to a period or a decimal point, or C is equal to the negative sign. Alright, so now let's do our read file object. So this is going to be where the algorithmic stuff comes into play. Alright, so we're going to have a bunch of variables to declare up top before getting into a loop, just because we're going to have a switch in the loop. So we need to initialize all of our variables before that. So we're going to have a string stream. So string stream str is equal to string stream, allocate default, then string stream read file. We're going to use this other method, the same method here, or a similar method. Pass in a reference to str. The file pointer will be fp, and the length will be 0, indicating that we want to read the entire file. Now we're going to have two stacks. So we have our object stack here, which is exactly what we want. However, we have to have another stack which will be for the keys in our dictionary. Because if we have nested keys, there isn't just going to be one current key. So for example, if we had something like object2, and then we had test1, like that. So if we had something like this, object2 would be stored as the current key. However, when we opened up this dictionary and added it to the stack, we would overwrite that current key with test1. So therefore, we need to have a stack of keys that we can push and pop to. So we'll have a dynamic array, stack is equal to dynamic array, allocate default or default allocate, and then similarly for dynamic array, key stack is equal to dynamic array default allocate. Alright, then we're going to have some state variables here, or we're just kind of a few variables. So boolean key open is equal to false. Then character pointer current key. This current key will be used just as a shorthand instead of having to pop from the stack several times. We're just going to store it in a variable. Alright, and then we will also have a JSON pointer as the current element, which is equal to null by default. So as I said before, when we find a comma, which is its own token, we want to push whatever the last element was. However, we can't go backwards, so we're going to store the last element, which would be the list. And if you're looking at the highlighted section here, this will be stored in current element, which is right here. So pop the list as the value that will be popped into the current element. All right, then we'll have some other, and with this, I guess, we can have JSON pointer list is equal to null, and JSON pointer object is equal to null. These will just be placeholders. And then we're going to have one state variable, which will be bool found decimal, and also bool found negative. These will just be for parsing numbers. And then some index variables. So unsigned integer next I, and unsigned integer object length. All right, so these are going to be all of our variables here. All right, so we'll start with our loop here. So for unsigned, int I is equal to 0, I is less than str.size, I plus equals object length. Alright, so we're essentially just going to be going through each of the characters, and we will skip how many ever characters were in the previous object. Alright, so the first thing we want to do is set the object length to 1, which will be the default. So most of these tokens, like the open bracket, the colon, the open bracket, the comma, close bracket, comma, the semicolon or the colon, those are all one character, so we're just gonna have that by default as the object length. All right, then we're going to get the character. So character C is equal to str to str at I, and then there's characters that we want to skip. So the white space we would just want to skip entirely because it does not add anything. So we're going to say if C is equal to a space character, or C is equal to a new line, or C is equal to a tab character, and we're going to have one more if C is equal to a colon, then we're going to continue. So this is just going to be the skip white space. So the reason why we don't need colons, even though I have it as having an action in the stack, we can simply just attach this condition onto the previous one, because when we have an open object, we know that after every value, we want to open up a key. So the key will just be started by default after the opening of an object, so after an open curly brace, and also after a comma here. So those will be the two the two ways in which we'll know that we have found a key here. So we're going to skip white space and colons. And then we're also going to have a validity check here. So bool valid is equal to true. And at the end of the loop, we will check to see if it was valid, and if it's not, we're going to break. So let's actually just write that now. So if not valid, then break. Now in between that, in between the initialization of the valid variable and then the check, we're going to have our switch. So we'll have a switch on C. Like that. And we're just going to go through all the characters. So we'll have a case, open curly brace, and then I'll break. So I'll just put down all the characters first, and then we will go through them one by one. Case, open square brace, break, case, quotation mark, break, case comma, break, case close square brace, break, the case close curly brace, break, and then default, which will be where we check for the other tokens. So default will just be all of these four over here, the numbers, the null values, and the booleans, and then we check individually for the other 6. Alright, so let's start with the dictionary. So the open curly brace. This should be relatively simple. We're simply going to start a dictionary here. And when we do this, we want to just add to the stack. So dynamic array, add last, pass in a reference to stack, and the element will just be Json alloc type, and pass in a JSON object as the type. So when we find an open curly brace, we just want to push an object onto the stack, and we push a pointer so that the memory persists after this method is popped from the call stack. And then we want to start a key. So key open is equal to true. And now, when we find a quotation mark, we know that we're going to be reading it into the key string and not into its own object or its own JSON value. And then for the list, it's going to be the same shit. So we're going to start a list. So dynamic array, add last, pass in a reference to list, or stack, sorry, and the element will be JSON alloc type JSON list. Just like that. Alright, so for those are the two instances when we are going to push to the stack. When we find elements, let me just turn this down this does seem kind of loud, so let me just turn this down a little bit, even though this is a bop. Yeah, so whenever we find a dictionary or a list, we're going to push those to the stack, because those are going to be, if we're thinking this as a tree in a tree structure way, these are going to be the nodes that will have children. Everything else is just going to be a leaf node. So all the numbers, the strings, the Boolean values, and the null values, those are all just going to be nodes. Those are going to be leaf nodes. They don't have any children, so we don't need to push them onto the stack, because there's going to be nothing to discover from beyond that. But with the list and an object, there are going to be children elements that we want to go to. All right, so for the quotations, we want to start a string. So start a string, and then we want to find the closing quote. So we're going to start with our next I counter. So next I is equal to I plus 1. Then while next I is less than str.size, we're going to determine if the next character is a quotation mark. So if str.str at next I is equal to a quotation mark and it's not an escape character. So and str.str at next I minus 1 is not equal to the backslash. And you have to do a double backslash because this is an escape character here. So if this is true, we would just want to break. Otherwise, we want to advance the counter. So next I plus plus. Alright, once we have found the string, because this reads the entire string, we want to set as the key or element. So we're going to first do I++ to advance past the first quotation mark. And then we're going to say object length is equal to next I minus I. So this is essentially encompassing these, it's encompassing these 5 characters here. So the L to the 1 excluding the quotations. And then now we want to determine if it's a key or an element. So if key open, then we want to store it as a key. So we're simply going to say dynamic array add last. So we're going to add to the key stack. So pass in reference to key stack. And then the string will be string stream substring length. Pass in a reference to string. The initial value or the initial character will be I, and the length will be object length. Just like that. So this gets a string using the string stream method that we created, and it just stores it. And then since we finished the key, we want to say key open is equal to false. Alright, and then else we have found we created a new string, so we're going to say current element is equal to JSON alloc type JSON string, and then current element dot val dot s is equal to string stream substring length, pass in the same arguments, reference a string I and then the object length. And then at the end, we want to say object length plus plus, just to push past that last quotation marker there. Alright, so that's the string part. So once again, this last line here, object length plus plus, just allows us to go past the entire string. And the reason why we need that is because if we were just to go to next I, so next I stops counting once it hits the closing quotation. So the index of the closing quotation is the final value of next I. So the substring will go from the first character to the closing quote, but it won't include the closing quote. So if we were just to not increment object length at the end, it would just find another quotation and it would consider that as an object, and it would just keep going and it would break the entire thing. Alright, so for a comma now, this is going to be a little, it's not going to be too bad, but this will be interesting. So with the comma, we're going to end the element, and we're going to determine if add to object or list, depending on what's at the top of the stack. So if current element, then if stack.size, so if we have something at the top of the stack, we want to add to the top list or object. So if now, all right, so this is going to be this if statement is going to be a little weird because we want to get the, or I can actually just store it here. So we're going to say JSON pointer stack top, or wait, no, I don't want to do that because then we have to initialize another variable. So we're going to say if the JSON pointer conversion of stack.list at stack.size -1, so stack that this gets the last element in the list. If this conversion to a JSON pointer, if that the type is equal to JSON list, then we want to add it to the list. So we're going to call JSON list add, and the list will be stack.list at stack.size -1, and then the value will be current element, just like that. And I absolutely adore C and C++ for this, because if we pass in a pointer, we don't need to have an explicit conversion as a parameter, because it will implicitly convert it to whatever pointer we want to, because a JSON pointer is the same as a void pointer, because in memory they are both just addresses to other memory. So we can simply pass whatever we wanted in there. Now otherwise it's going to be, we know it's a dictionary because those are the only two things that we add to the stack. So when we look at the first two cases, these are the only times we're going to be pushing to the stack. So we know it's either going to be a list or a diction or an object. So in this case, if it's an object, we're going to say JSON object put. The object will be stack.list at stack.size -1. The key will be dynamic array remove last, and pass in a reference to key stack. So we're taking the last key from the key stack and removing it, and the element will be current element. And then after this, we want to set the key open to true, because after each value in the dictionary, we want to open up the key again, because we know we're expecting another key. Alright, and then after the if statement, we're just going to set, after all this, we're just going to set current element is equal to null. Just so because it's added to the list, it's added to the stack or whatever, so we don't need to have this current element as a value anymore. Alright, 3 more cases. For the closing square bracket, we're going to end the list, and by that we mean we're popping from the stack. So list is equal to dynamic array remove last, and pass in a reference to stack. Then we're going to add the current element to the list. So if current element and list.type is equal to JSON list, then JSON list add, and the list will be list and the element will be current element. So if we have some value or some element, because there's no comma before the end of a list, we want to add whatever element we just finished before closing the list. And then, since we're ending this element, we want to set the current element as the list. So current element is equal to list, and then list is equal to null. Alright, and then quite similarly for the object, we're going to have end the object, and by that we mean we're popping from the stack. So we say object is equal to dynamic array remove last, pass in a reference to stack. And then we're going to add the current key value pair to the object. We're first going to see if there actually is a key, or if there is an object. So if current element, then we have something that needs to be added to the dictionary. So now we're going to get the key. So current key is equal to, or we actually don't need to store current key because we're only calling this once. So we can just say JSON object put. The object will be object. The key will be dynamic array remove last, passing a reference to key stack, and then the value will be current elements. Oops, there we go. And then we want to set the current element as the popped object. So current element is equal to object, and then object is equal to null. So the reason why I did make a mistake when I was writing this for the first time, I initially took in current key and popped it from the key stack even before checking if current element was a value. Because if this is not null, or if this was null, then this condition would not pass. However, we still would have popped something from the key stack, which would have been a higher level key, which would have fucked everything up. So we only want to pop it from the stack when we have a current element. And we also need to add to this condition and with object.type is equal to JSON object. Just like that. Alright, now for default, this is going to be where we are going to be parsing the other stuff. So we'll start with numbers. So if character is number, C, then we want to parse a number. So we're going to set our state variables, so found decimal is equal to false, and found negative is equal to false as well. Then found decimal will actually be equal to if C is equal to a period. So and then the found negative will also just be C is equal to a negative sign. So the initial states for found decimal and found negative will be contingent on the initial character. So just these conditions here. Now we're gonna, like with a string, we're gonna start our next I counter. So next I is equal to I plus 1. Then while next I is less than string.size and character is number, pass an str.str at next I. If this condition passes, then we're gonna say if str.str at next I is equal to a decimal point, then we want to say found decimal is equal to false. However, before that, we want to check if we already found a decimal. So if found decimal, we will say valid is equal to false and break. So we have an invalid number. And then we also want to determine else if str.str at next I is equal to a negative sign. And similarly, if found negative, then we have an invalid number. So valid is equal to false and break. And then outside of these statements, we're going to say next I plus plus. I mean, we can also convert this into just one if statement, just to, or wait, no, we can't. That's a mistake. And then also, when we find a negative sign, we have to set found negative to true. The found decimal should be set to true, not false. That was my mistake there. So when we find the decimal point, we want to set the found decimal to true, and the same thing with the negative sign. So when we find a negative sign, we want to set it to true. Alright, then next I plus plus, and then we iterate through the loop again how many ever times. Now outside of the loop, we're going to first calculate the length. So object length is equal to next I minus I, and we want to check if there's validity. So if not valid, then break. And then otherwise, we're going to say we have finished the number. So there's going to be two possibilities here. We have two types of numbers here, a float and an integer, and whichever type it is will depend on if we found a decimal point, and we have a state variable for that. So what we can say is, if found decimal, then we're going to allocate for a float. So we're going to store the float value. So current element is equal to JSON alloc type, and the type will be JSON float, and then we just want to store it in the float. So current element .val.f is equal to, now we're going to convert a string to a float, so a to f, just the library function, and the string will be string substring length, the stream will be a reference to str, and then it goes from I, and the length will be object length. And then similarly for an integer, so otherwise we're going to store an integer. So current element is equal to JSON alloc type JSON integer, and it will pretty much be the same. So current element dot val dot I is equal to a to I this time for an integer, and then it's going to be string stream substring length, same parameters, reference to string I, and then object length. Alright, so in this case we have found a number. So we found a number, but now we have 3 other tokens that we could possibly have. The null value, the false value, and the true value. So we have an if statement up here if the character is a number. Now otherwise, so else, before the break, we're going to have an else here, and we want to parse some keywords. True, false, and null. So we're first going to get the substrings of the specified lengths. So character pointer substring 4 is equal to string stream substring length. We'll have a reference to str, and it will go from I, and it's of length 4, and then same thing for a character pointer substring 5, which is equal to string stream substring length reference to str I and 5. So these are just getting the 2 substrings. I just want to make sure. Okay, yeah. So this has a boundary checking, so we're good there. So we get the substrings to compare based on what we want. Now we're going to call the string compare function. So if not string compare substring 4, and then JSON null string. So we're going to compare the substring of length 4 to the null token, which we define as a macro in the header file. And if that comparison results in a 0, then they are equal. So we'll set the null value. So current element is equal to JSON alloc type JSON null, and then object length is equal to 4. We need to update this length so that it goes past the token in the next iteration. Now else if not string compare substring 4 JSON true string, then we're going to set it as a Boolean value. So current element is equal to JSON alloc type JSON Boolean, and we just want to set the Boolean value. So current element dot val dot b is equal to true, and then object length is equal to 4 as well. And then finally, else if not string compare substring 5 JSON false s. So it has to be of length 5 because false is a word of length 5, and this will be a false Boolean value. So current element is equal to JSON alloc type JSON bool, then set the value current element dot val dot b is equal to false, and then object length is now 5 to go past the character. And then otherwise we have an invalid character or invalid token, so valid is equal to false. And then go out of the if statements, break, and then we're done with the switch statement, so we're done with that. And then if not valid, we want to break out of the for loop, and then after the for loop we now want to do some cleanup. So we have a few things we need to clean up here. So if we go to the top of our function here, we have a bunch of variables. So we have a string that we need to clean up. We have 2 stacks we need to clean up. We have a key that we need to, well, the key we cannot clean up because that may point to a value, and we don't want to free that memory. So we pretty much just have 3 things we need to clean up: the string stream, and the 2 stacks. So string clear, passing a reference to str. Dynamic array free, passing a reference to stack, and then dynamic array free, passing a reference to key stack. Now for the return value, we're going to say if current element, then we're going to return a dereference of current element. So we don't want to return a pointer, we want to return the value. So we're going to return a dereference. However, if this is a hash map or a list, it will still point to the same array or same hash map that the constructed one up here did. And then else we're just going to return a JSON null. Just like that. And yeah, that's it. That is our that's our parsing method. We will test this in half a second. I'll just sit right here for a little bit. Okay. So let me just recap on some of the general format, or the general format of this parsing algorithm. So we start by determining what token we have found. So the token, it could be one character. So if we start with the case of the curly brace, then it's just going to be the one character, and we will then push some hierarchical, I don't know how the fuck to pronounce that word, some element that will have children to a stack, similar to a tree traversal. We want to push parents to the stack and then pop them once we have finished all of their children. That sounds very ominous, but it is not eating children, it is discovering the children. So we push parents to the stack, and then so that will be for the object in the list. So if when we have an opening brace, here we add a list or an object to the stack. Now with a string, we determine whatever the string value is, and then we store it as a key or a current or the element. And then the general thing here is every time we find an element, we store it in current element, so that when we find a comma, or whenever we find a time to add to the top element in the stack, we have it stored as current element, which was just the previous element finished, or the previous finished element. Now for the comma, it's going to be something similar, where if the current element exists and we have something at the top of the stack, we want to add to the top list or the object, and then we just set the current element to null at the end. And then we advance. So we advance past the token, ending the list. So once we have popped a list from the stack, we have finished all of its children, but this list or this object was the child of some other node. So we want to set the list or the object as the previous finished element to be added to the next level. And at the end, once we have popped everything from the stack, the current element will be the last popped element. So the last popped list or object, which will be the highest level element in the JSON file. And then for the default, we just have the parsing cases where we set the according types. Current element will always be the return value from JSON alloc type, where we just pass in a type there. Alright, so let's go ahead and test this out. So in main.c, I'm going to comment out everything that we have here. I'm going to comment out everything but the output, and we're gonna determine that. So JSON out is equal to JSON read file, and the path will be test.json. Alright, so we're reading this into memory, and then when we run this, it should give us the exact same thing. Oops. Oop, okay, so we got some errors here. Alright, that's fine. Okay, did I misspell something? Oh, I did misspell something. Okay, that makes sense, yeah. I just misspelled this string stream substring function. So now if we run this, no. Uh-oh, that's not, fuck, damn it. No, it was so good, and then it was not. Alright, let me just print this out just to make sure it's all working. So printf %s str. Alright, so we read everything properly. That's fine. Alright, then I guess we're just not doing it. Oh, god damn it. Son of a bitch. Alright, let me print out the characters to see if we are advancing the tokens properly. Alright, so we found... Oh, this could be... Huh, okay, let me... It seems that there might be a problem with the number parsing method where it just... sets something as invalid. Alright, yeah, let me do something here just to confirm that theory. Alright, so yeah, it's determining that the 1 is invalid. Okay. So let me figure this out here. Ooh, I may have forgotten to do something. Hold on. Alright, no, valid is set to true initially. Alright, this is getting a little confusing, so let me close some windows here. I'm going to zoom out just for a little bit, just so I can see where I am. Alright, so I'm going to debug, and I will break in json.c at line 657. Okay. So next, so print found decimal, print found negative. Alright, so that's all good there. Alright. So we have good. Oh wait, no, so yeah, so the next character is the decimal. So let me just open this back up. Yeah, so we're at the point now. So found decimal is true, next I++. Or wait a minute, hold the phone. We can simplify this a little bit. We don't even need to check if found negative is true, because if found negative is, if we find a negative character after the first character, then it should just be invalid. So we can just remove that check right there and say that if the next character is a negative sign, then just set as invalid number, and we don't need to check that at all, because if the first character is a negative sign, that's fine, but it just cannot be present beyond that. So there we go. All right, so that's just a quick check there. All right, so debug, break, json.c 657, run, next. All right, so we found a decimal, good. Huh. When did, wait, print next I, print str.str at next. Where's the getting a 1? Oh, the number, okay. Okay, good. So everything else works. I don't know why the number parser is not working, but this is what it found. So we have a list 1 with 2 elements, a list 2 with a null element, empty list 3, empty object, and a string. All right, so I'm going to look at, so yeah, that's pretty much, that's that. That's the parsing. I'm not sure why it's reading it, the numbers as having negative signs, so that's what I'm confused about. All right, so let me debug here. So yeah, this works. It's just I'm not sure what's up with the negative signs. So I'll break at json.c 658 and I'll run. All right, so print str.str. Okay. Oh, so it's not there. So let me, I'm hoping that if I continue, no. No. Oh, you know why? It's because I put a single equals sign there. Okay. So str to str at next I must be equals to. Make sure that's a Boolean expression rather than just an assignment. Okay. Now if I run this, we should get, Jesus, wow, okay, that's great, wonderful. Alright, so this is exactly what we want. Perfect. And once again, you can see here that we have the keys and the nested objects ordered properly because we have a stack of keys rather than just storing one key and overwriting that every time, because this case may arise here, so we need to have a stack of keys. Alright, yeah, so that is pretty much all I wanted to do today. This was just a little algorithmic stuff here. But yeah, stack was super useful. This is pretty fun, very satisfying to figure this out. But yeah, so this is now a fully functional JSON reading and writing library, which I will likely replace the existing one with, just because this is more efficient and it makes more sense. Because I don't know if you guys remember, but the first time we did JSON, I don't know what I was thinking when I had the stupidest, like this weird ass method of getting the object and then passing in some very trivial parameters, and it just was not working. So yeah, this was this was bad. I don't know what I was thinking, but now this works, and it's in C2, which is awesome. So we have it at a lower level, yeah. So this will be more applicable to whatever. And yeah, I hope you guys enjoyed. Hope you learned something. This was definitely interesting to look through, especially in such a low-level language. But once again, these library files really helped out that we created in previous challenges. But yeah, until I think we're done with JSON for now in C, because we pretty much have everything we need. I might add a few more utility methods, but there's no real need to. I could add like addition or like other modifiers that would allow you to add or subtract from the numbers, but you can simply do that just by saying JSON object get or here, hold on. We can simply do this by just saying something like JSON list get, and the list will be JSON object get. Referenced out, the key is going to be list1, and then the index of the number will be 1, so dot val dot f minus equals 0.54f. So if we were to do this now, we should see that the 1.29 becomes whatever 1.29 minus 0.54. Oops. So yeah, 1.29 minus 0.54 becomes 0.75. So yeah, these are the modifiers that you can just pull, like that you can just use, and you can do all the number subtractions here, which is cool. But yeah. So yeah, there's a lot of, you can play around with this, see what you like, see what you want to do with it. But yeah, that's all I have for you guys today. Hope you learned something. Hope you guys enjoyed. And I'm planning on going to Shunting Yard, or going back to Shunting Yard and actually programming that next. And then next week will be a little busy for me, so I might not have a video out just because I have finals, so I will be very busy. So, but who knows? Maybe I will to cool down for a bit. But yeah, I hope you guys enjoyed this. I certainly did, and I will see you guys in the next video. Have a good one.